What we're doing now is we're solving equations that have rational expressions in them. So this is lesson 20.6.4, and then we have one more lesson after this, which we will cover tomorrow. The plan then, I suppose, is when we return from our Christmas break, we will have the Monday and Tuesday as review, and then on the Wednesday and Thursday we will be writing the exam for this unit. And then we have one very short unit at the end that we'll spend about 7 days probably, including the exam, on. So we're solving equations with rational expressions. And we're checking for extraneous roots. And don't forget that an extraneous root is simply, it's best to think of it as a solution to an equation that you get by following the rules of algebra, but it's just not really a solution. And when we're solving radical equations, equations with square roots, we typically find out whether the solution we got is valid or not by putting it back into the original equation. When we solve equations that have absolute value signs, you can do that, but a better approach is to write out what the subdomains are for each of the two equations and see if your solutions fit into those domains. What we're going to do for extraneous roots here is a little different, but it's actually simpler, I think. In the examples I'm giving you or that I've made up in this lesson, I've linked, I guess, in your notes to similar examples in your textbook if you feel that you need more help. Okay. The first thing to note is that we still have to factor everything completely. Whether you're simplifying a single rational expression or multiplying rational expressions or dividing rational expressions or adding or subtracting them, which we did yesterday and today, you have to factor everything completely. And when we rewrite this in factored form, you need to spread this out. Now on your paper, I'm not saying you should spread it out across the whole width of the page. I don't think that's necessary. I'm going to do so here because my writing compared to my spaces, it's a different ratio than what you have on paper. So I'm going to write this out, and I'm going to have 2 over, then I have z plus 4, I have z plus 2, z minus 2, because z squared minus 4 is a difference of squares. And I'm going to leave a fair amount of space here. And then I have 10 over, and I can factor a 6 out and have z plus 2. I hope you can see that's why I put a line through the middle of my z's. 2 and z look pretty close to each other sometimes. And I'm going to leave some space and write equals 1 over z minus 2. Now it occurs to me that I'm going to rewrite this one more time. If you want, you can take a little bit of a shortcut. The 10 over the 6 can reduce down. Georgia, at lunch, we were working on a question where when you were adding or subtracting rational expressions, if you didn't notice that you could cancel some factors in a single one of them, you got into a pretty deep hole that you couldn't get out of. That's not going to happen here. If we don't notice that 10 over 6 can be reduced down, it's not going to ruin things for us. But I am going to rewrite it with a 5 here and a 3 there. So now I have 2 over z plus 2, z minus 2. And I'm going to leave some space. I can write this as 5 over 3 times z plus 2 equals, I'm going to leave some space, 1 over z minus 2. And after we finish this question, you'll start to be able to gauge how much space you need. If you look at, I want us to compare something here. I want us to compare this equation, which I'm going to freeze up on the monitor on the right, to even something as simple as this. What you're looking at on the screen on the left, what you're looking at in the video, if you're watching this on video, is a sum of rational expressions. And there is no equal sign anywhere to be found. There is no equal sign there. Okay? When you look at the equation that we're trying to solve, clearly it's an equation. When you look at example A, this also has rational expressions, but there's an equal sign. And in both of these, you need to be able to identify the lowest common denominator. So I'm still going to leave this up on the right. And this is a question we didn't do, but what is the lowest common denominator here? Well, that's easy. It's a plus 7, a plus 5. Would you agree? And here's the question I want everybody to think about. Why are we going to find the lowest common denominator in what's on the screen right now? What use is it to know what it is? Or what do we use it for? Colin, do you know? Maybe I'll ask the question this way. What would be our next step here in adding these together, which was yesterday's work? What would be our next step? Do you know, Georgia?
So, like, put them as a common denominator so you can add the two together?
Right. We want to convert both of these to fractions of the same denominator. So what you would be doing here is you would be having a over a plus 7 plus 2 over a plus 5. And you would say, well, I need to multiply top and bottom by a plus 5 here, and top and bottom by a plus 7 here. And you would get a times a plus 5 plus 2 times a plus 7 over a plus 5, a plus 7. You with me? But notice that this thing has a denominator. It has a denominator because the original expression has a denominator. We're finding a lowest common denominator when we're adding and subtracting rational expressions to get a common denominator in the result. Let's go back now. To the question that we're working on. Let me unfreeze that. We still find a lowest common denominator here. Okay? We're still going to find a lowest common denominator. And it's pretty easy. The lowest common denominator would have to contain a 3, a z plus 2, and a z minus 2. Just ponder that for a second. Okay? Why are we doing this? We're not doing it now. There's an equal sign. This is an equation. We are not doing it to convert everything to common denominators. When you want to solve an equation, we would prefer not to have fractions. So what we do is we multiply both sides of the equation by that common denominator. And I mean, I could put brackets around the whole left side and say times that. I prefer to write times that common denominator for each and every term. I'm allowed to multiply an equation, both sides of an equation, by anything I want. If you go back, and I feel as though I want to, when you go back over here and look at this example, I've lost it. There it is. Notice we're multiplying top and bottom by those things. You can't just multiply everything by a plus 5, a plus 7 and start canceling stuff because there's nothing on the other side of the equation that's going to balance it. There is no equation. And this is the thing that I think people mix up between yesterday's topic and today's. They know that when you add rational expressions, it involves an LCD. They know that when you're solving an equation that has rational expressions, it involves an LCD. But you use the LCD, the lowest common denominator, for different reasons. So what happens here, there we go, is kind of a thing of beauty. That when you look at this, this is a single rational expression. And I am allowed to cancel any factor that appears in the numerator and denominator. And when you look at this, this is a single rational expression. And I am allowed to cancel the 3 with the 3 and the z plus 2 with the z plus 2. This goes back to something, well, I've taught you this already. We've talked about this before, that when you have fractions, you want to multiply by whatever you need to get rid of the fractions. And what you need to use is the common denominator. Over here, when you consider this, you can cancel the z minus 2's. And now you have to look carefully at what you're left with. You're left with a 6, 2 times 3, plus 5 times z minus 2 is equal to 3 times z plus 2. You're left with, everybody, and I just want to make sure I got all of the surviving pieces, you're left with something which isn't even going to be quadratic. It's going to be linear. It's going to be something a grade 9 student can solve, or maybe even grade 8. 6 plus 5z minus 2 equals 3z plus 6. No. Equals 3z, yeah, plus 6. This is where I screwed up. This is a 10. Thank you, Georgia. So 6 plus 5z minus 10 equals 3z plus 6. Well, we can clean it up a little bit more, I suppose. I don't quite frankly care how it is you get to the answer from here. I'm taking 6 minus 10, which is negative 4. That means if I add 4 to both sides, I get 10 here. If I take 3z away, I get 2z, which means z is equal to 5. You know, that first step, well, 2 steps, finding a common denominator and multiplying everything by it, that is huge. That changes it from a Math 20 problem to something that has nothing to do with Math 20. There is an issue here, though, and it's that we had non-permissible values. That up here, when you look at all of the denominators, we have 2 non-permissible values of positive 2 and negative 2. All we need to do to verify our solution is ask ourselves this: is z equals 5 permissible? The answer is yes, because it's not 2 or negative 2. That's it. You don't need to put it in and check. Let's try one more. And, you know, I was going to point this out to everybody earlier, that you should be pretty impressed with yourself in terms of some of the stuff that you know how to do now. Like when you take a look at that, or when you take a look at the question that somebody had asked about, that's pretty impressive. If on day 1 you walked in this classroom and I said, in 3 months you're going to be doing this, some of you might have run for the door. I don't know. You've come a long way, is my point. And you will continue to grow as you get into Math 30. Let's take a look at this next one. It looks complicated. It's not when you break it down. This is 3x over x plus 2. Leave some room because you're going to be multiplying everything by whatever is necessary to clear those denominators. Minus, we have a 5 over an x minus 3. And luckily, this is equal to negative 25 over x plus 2, x minus 3. I say luckily because that's going to be our common denominator. There's another way to look at what's going to happen here. We don't have to say this. You don't have to say, what's the common denominator? You know what you could do, and this is how I used to always teach it, because it was how I was taught, is you want to ask yourself, how do we get rid of all of these denominators? So how do I get rid of the x plus 2? Well, you know what I do? I multiply everything by x plus 2. Would you agree? Okay. And that will get rid of this x plus 2, and it will also get rid of this x plus 2. But what it doesn't do is get rid of the x minus 3. So you could say, well, that means I have to multiply the top of this by x minus 3. But it's an equation. I have to do the same thing to everybody here. And in the end, I hope you see, so that's going to clear this and this. But I hope you see that in the end, we're just multiplying every term by the lowest common denominator. So what happens is the x plus 2 cancels here. The x minus 3 cancels here. And here we get a huge get. Huge jump forward. Everything cancels from the denominator. What are you left with? You're left with that. And I know sometimes I talk too much maybe about Math 30, because this isn't Math 30, but you're heading in that direction, most of you. What I will often tell my Math 30 students, and they get frustrated with it, and it's not that they get mad or anything, it's just a frustrating thing. They'll write an exam and they'll lose 4 marks out of 20. Just 20%. Isn't it? Yeah, it's 20%. Because they forgot to multiply a negative through, or they made a mistake that's a grade 8, 9, 10, 11 mistake. As you do more and more, as your brain gets fuller and fuller with different math ideas, we just assume you can carry on with all that other stuff. And this is why when you're dealing with algebra like this, you need to take your time. You don't want to rush. You don't want to get it wrong because you multiplied 2 negatives together and you wrote negative, which happens. I know it does, but you want to try to minimize those mistakes. So what do we get here? We get 3x squared minus 9. And don't get me wrong, you're going to make mistakes, right? You know, I make mistakes. I make mistakes sometimes, I think, because I get stressed out in front of a group of people. I do. There's a level of stress in presenting something. But even if I'm working on my own and nobody's bothering me, I make mistakes. You're going to as well. You just want to minimize them. So this is minus 5x minus 10. 3x times x is 3x squared. 3x times negative 3, well, there you go. Good idea to check, is negative 9x. And I have told you this before. With algebra at this level, you should be double checking every line. So 3x times x is 3x squared. 3x times negative 3 is negative 9x. And then I have negative 5x minus 10, and this is equal to negative 25. But now we're on, familiar ground. This is 3x squared minus 14x plus 5 plus 15. We get you to do a discriminant calculation for me. B squared minus 4ac. This is equal to 0. $16. It's definitely factorable. So I'm not going to write that down. You hopefully know what we're talking about here, that the discriminant b squared minus 4ac, if it is a perfect square, it's factorable. X, 3x, I don't know what else it could be. Well, it can't be anything else. It can't be anything else. The 15, might it be 1 and 15? Maybe. I don't know that in over 35 years of teaching I've ever seen something factorable like this where it is 1 and 15. I honestly don't think I've encountered it. Doesn't mean it can't happen. I'm guessing it's 3 and 5, and if it's 3 and 5, I guess it has to be that, because I can't put the 3 with the 3x. If I do, I create a common factor. These would have to both be negative, I suppose. Negative 9, negative 5 is negative 14, so we get negative 14x. Okay. So we set each of those linear factors equal to 0 and we solve. Are we okay getting x equals 3 and x equals 5/3? Okay. So any questions with that example? Yeah.
Wouldn't x equals 3 be useful?
Excellent. That's why I asked. Any questions with that? You have to look up at the top, and at the top there was a factor of x minus 3, which means x can't equal 3, because then the original expressions in the equation are not defined. So yes, your non-permissible values are x is not equal to negative 2 or positive 3, but positive 3 is one of the numbers we got. So we strike it from the list. It's not a solution. And I don't think you really need to explain that. Well, I mean, I shouldn't say that. If it's a written response question, you should probably make a note that x is not equal to 3 because of a non-permissible value. One final example. Let's rewrite this. Look at how I wrote that 5. I hate that minus 5, just where the 5's kind of directly across from that bar. Remember I was telling you I always forget the name of this thing? It's called the vinculum. Pronounced ving, as in V-I-N-G, and then culum, vinculum. I remembered that I always forget it, so I decided to look it up. What are we going to do here? We're going to multiply everything by 2x minus 1 and x minus 2. 2x minus 1, x minus 2. 2x minus 1, x minus 2. By the way, when I looked it up and saw vinculum, that did not ring a bell. So it's been decades since I've actually seen that word. Cancel. Cancel. Nothing cancels. We're left with then 12 times x minus 2 equals 2 times 2x minus 1 minus 5 times 2x minus 1 times x minus 2. By the way here, if in your head you've somehow convinced yourself that this is some kind of type of cross multiplication, take that and dispel it from your existence. It's got nothing to do with cross multiplication. I say that, and some of you, I can tell, are looking and going, well, how would that work? It doesn't. But some people think they're cross multiplying, and if you are one of those people, you got to get rid of that idea. So 12 times x minus 2, I'm just looking up here and double checking, equals 2 times 2x minus 1 minus 5 times this. So 5 times this. 5 times 2x minus 1 times x minus 2. So 12x minus 24 equals 4x minus 2. Okay. So when I'm going to write some stuff here. You don't have to write it, but you might want to. Normally what I would just do, everybody, is I would say 2x times 2x is 4x squared times the negative 5 is negative 20x squared. Okay. But if you want I'm going to edit that out. Normally what I would do is I would just say 2x times x is 2x squared times negative 5 is negative 10x squared. However, if you want to write out the FOILing first, maybe even as an entire step, you can. I prefer for something like this just to multiply it out, and I keep track of it in my head. 2x times x is 2x squared. My outer product is negative 4x, and my inner is negative 1x, which is negative 5x, and then my final product is 2. So the negative 5 times the 2x squared is negative 10x squared. The negative 5 times the negative 5x is 5x times 5 is 25x, and the negative 5 times the 2 is negative 10. You might decide to clean this up first, and I'm going to double check all my stuff here. 4x plus 25x is 29x. I have minus 12 and negative 10x squared. You might decide to do this first before you start moving everything to one side. I think many of you could probably go from here to this line. I think you probably could. So what does that give us for a discriminant? I'm a little more optimistic about it being factorable. Have you got a discriminant?
I got 27.7 every
After you take the square root.
Yeah.
Yeah. So can anybody else confirm that the discriminant will not be positive? Yes? No, I mean not a perfect square? Okay. So this is not factorable, which means x, you know what? The fact that it's not factorable makes our lives easier, because we're just going to write out what it is with the quadratic formula. We don't need to even worry about factoring. Negative b plus or minus. Now, Zachary, do you have that number before you square rooted it?
769.
1769. I'm guessing 1769.
It's just 700, not 17. Just 769.
769.
Yeah.
Okay. I'm going to, I think maybe 9 divides into it. Does 9 go into 769? Maybe not. No, I don't think there are any numbers that go into it that's a perfect square. And that, again, makes our lives very easy over 2a, which is 20, because we don't even have to simplify this. That's the answer. And I hope you see that neither of those two answers are non-permissible. The non-permissible values of x would be 2 and 1 over 2.